Now we need to identify some angle pairs associated with every transversal. To make that a little bit easier, I'll just number some of the angles that have occurred in this diagram here. This will be angle 1, 2, 3, 4, 5, 6, 7, 8. Okay? And the first pair of angles I need to talk about are called corresponding angles. Corresponding angles, as an example, would be angles 1 and 5, or 2 and 6, 4 and 8, or 3 and 7. Those are all corresponding angle pairs. Corresponding angles occupy the same position relative to the transversal. Here's what I mean by that. Think of this as being a road. If I come to this intersection, I'm on the transversal, and I look across this corner, this would be sort of with respect to the intersection, this would be the northeast corner of the intersection. That's angle 6. If I come to this intersection, angle 2 is the northeast corner. Those two corners, the ones that correspond to each other, the ones that are the same relative to the transversal, and its intersection with the lines, really, those are called corresponding angles. 2 and 6, again, 4 and 8, 1 and 5, 3 and 7. Corresponding angles. They occupy the same relative position at these different intersections. The next angle pair I need to introduce is called alternate interior angles. Alternate interior angles. Alternate interior angles, we need to look at this phrase and sort of discern what these two different parts mean. Angles, we know what that word means, but what does it mean to be alternate and what does it mean to be interior? So when we talk about this idea of alternate, that word refers to the angle's position relative to the transversal. Okay? Alternate sides. So for instance, angle 2 and angle 3 are on alternate sides of the transversal. Angle 1 and angle 8 are on alternate sides of the transversal. So that's what the first word means. Alternate means opposite sides of the transversal. Interior refers to the angle's position relative to the two coplanar lines. Okay? So when I talk about angles 3, 4, 5, and 6, they're all interior angles. They're all inside of these two coplanar lines. So when we put those two terms together, alternate interior angles, we're talking about angles in here, 3, 4, 5, 6, and we're talking about alternate interior angles. Specifically, 3 and 6, that's one alternate interior angle pair, and 4 and 5. Okay? 3 and 6, 4 and 5. Those are my alternate interior angle pairs. 3 and 6, 4 and 5. So far in this single diagram, we have corresponding angles, that's 1, 5, 8, 4, etc. We have alternate interior angles, 3 and 6, 4 and 5. There's a third category, which is same side interior angles. Same side interior. Okay, just like when we talked about alternate interior angles, same side refers to the angle's relationship to the transversal. So 4 and 6 are same side. 3 and 5 are on the same side of the transversal. Interior still refers to the position relative to these two coplanar lines. So when we talk about the same side interior angle pairs, we're talking about 4 and 6, for instance, or 3 and 5. 4 and 6, 3 and 5. Okay, so far I've talked about parallel, perpendicular, and skew lines. I've also talked about some angle pairs that exist when you're dealing with a transversal. I just want to point out a couple other things because there are some angle pairs here that we've already discussed, and you should already be familiar with those. For instance, if I look at angles 5 and 8, well, those are vertical angles. We already know what their relationship is. They're congruent. Angles 2 and 3, also vertical angles. 1 and 4, 5 and 8, 6 and 7. Those are all vertical angle pairs, so we know about those. Also, if you look, we have angles 3 and 4. We have a name for that angle pair. That's called a linear pair. 2 and 4, 1 and 2, 1 and 3, all linear pairs. Down here, 5, 6, 6, 8, 8, 7, 7, 5, all linear pairs. So when we draw a transversal, there's a whole lot of stuff going on there. We're going to begin to develop rules that will help us sort of run through these angles pretty quickly and draw some conclusions. But for now, just be aware that the things we've already discussed, vertical angles, linear pairs, they're still on the table. They're still very much active here in our thinking. And now we've just got 3 more pairs to at least be aware of. I haven't talked about the rules, by the way, that govern any of this, but I'm just introducing you to the names of the angle pairs. Again, corresponding angles, alternate interior angles, and same side interior angles. The next thing we need to do is talk about 2 postulates, the parallel line postulate and the perpendicular line postulate. They're pretty straightforward. The structure of the 2 postulates is almost identical, so let me just show you how those work. Okay, we'll start with the parallel line postulate. It's a bit of a mouthful. Parallel line postulate says, given a line and a point not on the line, there is exactly one line that passes through the point and lies parallel to the given line. Let me show you what that means. If I give you a line, such as this one, call that line L, and a point not on the line, we'll call that point here point A. There is one and only one line that passes through point A and is parallel to line L. I'll just draw that so you can get an idea of what it might look like. It maybe would look like this. Not like that, like that. Okay? There's one line that passes through point A and is parallel to line L. Notice a couple things. First of all, there are an infinite number of lines that are parallel to line L, such as this one, or that one, or this one. And you know there's an infinite number more above or below. But there's only one line that's parallel and passes through point A. Likewise, there's an infinite number of lines that pass through point A. You can imagine a whole bunch of them. They go in every direction. But only one of those lines is also parallel to line L. So there's only one line that passes through the given point and is parallel to the given line. That's the parallel line postulate. The perpendicular line postulate is very similar. And to show you the perpendicular line postulate, I'll just erase some stuff here in the parallel line postulate and replace it. It says, I'll now change this to read the perpendicular line postulate. Given a line and a point not on the line, there is exactly one line that passes through the point and lies, you guessed it, perpendicular to the given line. Let me just clear that up a little bit and see if we can make sense out of it. So let's just start with a fresh diagram. We have a point, we'll call that point B. And we have a line, and we'll call that line M. And you'll notice that point B is not on line M. The perpendicular line postulate says that there exists only one line that passes through point B and is perpendicular to line M. Just as we talked about the parallel line postulate, notice this. There's an infinite number of lines that are perpendicular to line M. Any of these lines that I could draw in here, I'll use the red marker, such as this one, or this one down here. There's an infinite number of lines that are perpendicular to M. But only one of those lines passes through point B. That's this one right here. Likewise, as we said before, there are an infinite number of lines that pass through point B at every possible angle. But only one of them is perpendicular to line M. That's the perpendicular line postulate. So, quick review. The 3 things you should be able to do when you come out of this lesson, after you've watched this video. Number 1, you should be able to recognize parallel lines whenever you see them. You should be able to recognize perpendicular lines. And you should be able to recognize and imagine skew lines. Okay? Skew lines, again, are a little harder to put on paper because of the fact that they only exist in 3 dimensions. After that, you should be able to look at transversals and be able to identify some of the angle pairs that exist in transversals. We have corresponding angles, alternate interior angles, same side interior angles. Also, don't forget that vertical angles and linear pairs are still up for grabs, so to speak. And the last thing you should be able to do is articulate and understand both the parallel line postulate and the perpendicular line postulate. I'm going to make a short video just to show you how to do the constructions on parallel and perpendicular line postulates. You should look for that video. I will go over that tomorrow in class if anyone has questions. And as always, if you have questions, please shoot me an email.